Hello! Sanding is an important operation when you prepare the surface for paint application. Handheld sanders with round pad are mostly used for this operation. Orbital or rotary and round sanding disc for them accordingly. For more than 1 year, communicating with craftsmen engaged in sanding of various materials, such as wood, panels, plastics, metals, and etc., I often came across the fact that criteria for choice of abrasive were diameter, grade, and of course price, while much more significant features, such as uniformity of the scratch marks left by abrasive disc, its performance and durability, were determined by masters while using. Then craftsmen made a decision whether to stop on one or another choice of abrasive. Today I'll try to evaluate disc's quality using the example of the new abrasive brand, 1Tech or 1T, how we call it sometimes, the box that I hold in my hands. First, let's give a visual tactile assessment. Look at the product with our eyes, feel it with our hands, look at it under a microscope, and so on. Later in practice, we will seriously load this abrasive. For this we have everything needed, as you can see. Well, there is a standard box in my hands, quite aesthetic, made of high-quality cardboard. Of course, it would look better if it was made of bison skin or plastic, but nevertheless, there is enough information. Grade, manufacturer, all the necessary attributes that is usually present on manufacturers' abrasive boxes. Now, as for discs. You can see the color. Where do we start to analyze the product? First, very important point. We'll determine the backing of these abrasives. The film is good. Usually, a large number of abrasives with 150 or 125 mm diameter are produced with one of two types of backing, film or paper. Paper is much lighter, simpler and cheaper. The film has much more advantages to my mind. First, the film is more durable, while the paper can be easily teared. Paper can be teared with your hands, or it can also be easily torn while in process of sanding of some surfaces. Edges, metal transitions to other surface materials, and so on. The film provides with more uniform disc fitting to the tool's pad, while using sander with an inclination, while sanding the edge zone of product or hard edges, metal, or places where the metal has welding elements. The film, in contrast to the paper, doesn't break, doesn't collapse, and the tool's pad doesn't wear out. If we use film, the grain doesn't crumble when disc gets wrinkled. Abrasive works longer. Film rigidity is adequate to its grit. This is P80. It is more firm and stiff to keep its shape and provide disc rigidity under high loads. If we take P320 or higher grit, it is much more elastic. There is P1500 in my hand. It can be called delicate, elastic, but at the same time, film doesn't lose its basic properties. It will retain on the pad and stay stable while processing top coats. Let's check fastening system. It is standard. Velcro. It keeps well on the pad and obviously not going to fly off. It can be removed quite simply, but at the same time, we see that retention system is strong enough. I don't think that abrasive disc is going to be removed 20 to 30 times, but in case of 10 times, fastening system will hold it well. Obviously, there are holes for sanding dust extraction on the discs. The way they are made and its appearance are also very important. The way the holes are made can significantly affect the uniformity of sanding marks. It is clearly seen here that holes at different grades and quantities. In this case, there are 7, and there are 15, where cut down from the side of the abrasive grain. I mean from here. As for cheap abrasives, the holes can be made flippantly there, which causes micro tears. The edge can be bent towards to the abrasive, the working surface of the disc, which means it will cling to the surface and scratch it. The main thing is that these inaccurate cuts are stress points, which can simply collapse the disc while sanding. So, 1Tech backing is okay, but the main purpose of the abrasive is to sand and provide good performance. Uniform marks without deep scratches. The cutting ability of abrasives depends on the type of grains. There are several types of grains, which are mostly used for discs: silicon carbide and aluminum oxide. As you know, silicon carbide is harder, cuts better, but it's brittle and grains break down quickly. Aluminum oxide is more durable, but it has less hardness. One tech is something in between. Aluminum oxide hardened with a high temperature treatment. This grain is durable and provides excellent performance, speed, and surface quality. However, even the best grain, alas, is not a guarantee of perfectly sanded surface. The most common abrasive problem is non-uniformity of grain protrusion. If among the abrasive grains at least a few stick out in relation to the rest, they will leave noticeable scratches on the surface. The same can also happen in case of uneven grain distribution over the backing surface. Let's see what we have with one tag. There are no complaints about the surface in microscope lens. The grain size is visually equal. Seamless distribution is uniform. Such quality can be achieved with electrostatic application of grains, when they are not just poured onto a backing, but are applied onto it in electrostatic field. That is how they provide an accurate positioning. Each grain is in its place. By the way, under the microscope we also see that one tag has a stearate coating. Stearate is transparent. You can sometimes meet the white one in discs of other brands, but generally speaking, the presence of stearate coating is a definite advantage. Many manufacturers do not use it. For example, this disc does not have stearate. Why is stearate coating used? Stearate significantly reduces the adhesion of sanding dust to the disc. Stearate-coated discs clog significantly less and therefore last longer. Not clogged disc has less surface friction. The working area doesn't overheat, which means fewer defects and damage risk, both for the surface and abrasive disc. So, what do we have with the preliminary, visual and tactile analysis of the new one tag? Positives: strong but not too rough film backing, accuracy of the holes, inward orientation of the hole edges, hard but not brittle grain, their uniform size and distribution over the surface, their correct orientation, achieved through the electrostatic application, stearate coating, which reduces the clogging of the abrasive and prolongs its service life. A little later, we will return to the practical tests of the abrasive. We're not going to spare it. Now we will put the abrasive directly to the test. First, we will check how much the presence of the stearate coating affects the reduction of abrasive clogging. I suppose comments are not needed. Now, let's repeat the same test with the coarser grit on the solid pine wood. Our experiment proves that one-tech abrasives honorably passed all the tests. They show high strength even while sanding edges and provide low clogging, while undoubtedly positively affects its service life. Thank you for your attention and see you soon.